Hi and welcome to my playhouse. Today we are at the computer in the living room and I'm gonna try and show you something about 3D rendering and servers and how they don't use their cores as good as they could, but we're gonna find that out. And there is ways around that actually, but it takes a bit more work, and this video might become a bit complicated because there's so many aspects of this, and to show this I have to use some rather complicated 3D rendering stuffy that I don't fully understand, but I kind of do know how it works, but I am not able to produce the graphics for it, so I borrowed this from a buddy of mine. Well, we are making this film together, so let's switch and see that. So here we are at my screen with me in the corner. I have my vCenter here, and right now it's showing you my good server. That's the Lenovo/IBM X3650 Model 4. I installed server 2019 on this in our live stream just the other weekend. You might have seen these servers doing that live stream, and these are for rendering out 3D Studio Max. We have made a manager. That's a server where you mingle and set up the shots and send them to these three servers down here, which is it's kind of workhorses. Yeah, why do we have 3-4 servers like that? Well, that is what we're gonna go into. So let's see this. I believe I have it open here. This is the manager. It looks like this. It has 3D Studio Max. It's called Autodesk 3ds Max 2018 installed. And this is it's part of our submarine movie that I have done behind the scenes on that and showed you that. And it needs some special effects. And this is one of the scenes that my buddy has made. If we see this view down here, we should be able to see some particles flowing by. If we press play, it shows the screw of the submarine making waves in the water and disturbing that. So we can stop that. And it's only the first 100 some frames where there is really some particles. I think 150 or something like that. Okay, 175-ish. So water particles, air bubbles, the submarine turning screw, well, everything adds up, and this will take a long time to render, even with a very good workstation. So what you do is you set up a network rendering so that you can have multiple machines rendering this. But also, if you just have one machine, like if you have one big workstation, it might actually be a good idea to have a couple of virtual machines working on this as well. So we have set that up, and this is what it looks like. It's called, there are multiple ways of doing this, but we are using the built-in stuff. This is called Backburner, and it connects to the 4 servers. We have server 1, server 2, server 3, and server 4. And I have tested different jobs, and I just came up with a test scenario for this. So if we pick job number 4 here, we can see over here in this window that I have done the first 4 frames of this. And each of these frames, the first frame took 2 minutes and 34 seconds. And then the time dropped considerably. And the next 2 frames are about the same. What I did, I just added up all of these seconds, like the start time here and when was it done. And I calculated that to be 425 seconds. There is one thing that I would like to add to this, and that is that I have gone ahead and I have only given this virtual server, there, server 1 here. Let's go and see the settings for that one. I have given that just one virtual CPU. Right now it has one CPU. This server itself, well, it has 32 logical CPUs available. Each of those are 3.6 gigahertz, but it has 32 of those. So I wanted to check out how long does it take to render some frames on this with just one core, and that took 425 seconds. So what happens if we give the server some more cores? Well, I think we should try that. This server runs with hyperthreading, so really it only has 16 real cores, and then it has 16 hyperthreading cores. Total logical processors is 32. So if we give it everything it's got, that should make the server considerably faster, right? It sure will. So I think we should do that. I have the server right here, that one, and it is running the back burner server here. Let's shut the server down. We need to shut it down to alter the amount of cores that it has. So shut it down. Fine. Go back to the server. It's over there. It will be shut down in a second. There, it's shut down. So now I can go up to action and I can edit the settings there. And we will see that it has just that one core. So let's go in the other direction and just give it everything. Cool. Okay. And we will boot the server again. Power on. I have to go on to the server because the back burner server does not start by itself. I could set that up, but yeah, I better not mess with this. It's very quick at booting. There, I put the back burner out here, so we'll start that. We will see that it will be accepted by the manager. That came right there. So now it's ready to do more work for us. So we'll minimize that, and we will go to our manager, which is over here, and we can see that there are 4 servers available. I'm just gonna be testing server number 1 right now, so just gonna check they are still available. Cool, minimize that. The view that we are rendering is this one. That's physical camera 2. That's the one that is being rendered out. So we do that by going up to render, and we go to render settings. I'm not gonna alter anything. I'm gonna do the same test again. We can see that the resolution is 1200 times 503. That resolution is gonna go considerably up during the final rendering of this, but this is just test rendering. So up here we can select submit to network rendering, and that does so that, well, you can see here another screen pops up. We can connect to the servers that are available. I have these 4 servers available. I can pick this one, server number 1, and tell it oh, I have to change this number, otherwise it will complain. Tell it to only use that one server that I have selected there, and submit the job to that. But before I do that, I think we should open up so we can see what goes on there. So we have the manager here and the server there. So when I submit this job, which I do down here, we should see this. It's just asking if it's okay to overwrite the test files. It's fine. We have submitted that. So the manager goes back to I can work on that. I could send on another job or something, and we can see here that the server itself is launching Autodesk 3ds Max 2018. That came there. Hoping that it will pop up and show us what it's doing. It's going to be rendering those 4 frames. It's pretty normal for the first frame to be slow because the server has to do all kind of weird stuff, and that's why I picked to do this on 4 frames instead of just 1 frame. So it's doing something there. Okay, Now it renders our submarine here, and this is very quick. That was 1 frame, and it's gonna do another one. It's not that much alteration right now. That was 2 frames. So each of those little squares you see, that represent 1 core. And there are some squares that takes longer than others. That's because, well, the harder calculations. It's done. So we can go back to our manager here, and we can open up here. And we can see that was this test number 5, and that took, we started at 11:24 and it had completed 11:25:37. So that's the hours, minutes and seconds. So it took 1 minute 35 seconds. That comes out to 95 seconds. Yeah, just about 95 seconds. So that's from the start time here to the end time there. So if we look at the project that I did before with just 1 core, we could see that, well, that was 425 seconds. So I have cheated, and I have started a spreadsheet on that. So here we have, I started out by 425 seconds for 1 core. Down here, I'm gonna put in this 95 seconds, and if we take 425 seconds, which is 1 core, and we thought, well, we have 32 cores now, so we have to divide that by 32 cores. That comes out to 13.2 seconds, right? So the real number, if we could calculate that way, 13, we're just gonna round it down to full second, 13 seconds. And we get some lines out here. The blue one represent what that kind of calculations would do, and the red one is the real time. So up here, that was one core, and down here is 32 core. I also did this with 4 cores, so that came out to be 146 seconds. I have not calculated that, so let's see. If we take our 424 seconds and divide that by 4, we get 106 seconds. So already now we can see that this is not following the same line. I'm gonna do a couple of more, and we can kind of see the line being drawn as we do this. I can probably tell you already it's gonna go halfway. Okay, I have been working hard here, and well, you can see my spreadsheet here has a lot of new numbers. I have calculated all of these times. Like the 1 core took 425 seconds, so I have just divided 425 seconds by the number of cores. That should, well, if you have 10 cores, it should only take 1/10 of the time, right? That was the strategy anyway. And that's the blue line. And you can see that blue line is uninterrupted because it was pretty easy to calculate all the numbers while it was doing other stuff. So that was all good. Then I have real numbers that I have rendered here. In the render test, I have now done a total of 15 rendered tests. Well, there was one there already. So we can see that 1 core takes 425 seconds, 2 cores really takes 257 seconds, and 3 cores, 4 cores, 6 cores, and so on down there. Especially at the bottom here, where we can see that 32 cores should take 13.3 seconds, but it takes 95 seconds. Yeah, that's not the lowest number really, because here at 16 cores, well, it should take 26 seconds 26.6 seconds. For those 4 frames, I have altered this up here. This is really 4 frames. It takes 88 seconds here. And a funny thing, if you see the graph here, you can kind of see the red dots. And the lowest one, the one that is fastest of all of them, is this 16 cores. And that's because this server has 2 8-core processors, a total of 16 real cores, and the rest of them are hyper-threading. So we can see doing this test, hyper-threading does not do anything good for us. 16 cores is the lowest number we have, 88 seconds, and then it goes up again, not by much, and here 24 cores, it even drops a little bit, and then it goes up and down. But it's a few seconds. It might alter if I did this again, but we can definitely see that hyper-threading is not a good thing here. And the last thing I have added here is how much do we really lose of performance when we are adding these cores. So one core I have set to 100%, and then I've calculated how much do we lose. So just adding one more core means that we actually lose 17.3% of the performance of the next core, or the total performance compared to what we would expect. If we have one core, well, we would be able to do 100%. If we had 2 cores, well, we should be able to do 200%. But we are losing 17.3% compared to that, and so on. And it goes up drastically. So already here at 8 cores, we are only just about 50% of what we would be expecting. And it, well, at 16 cores, we are almost losing 70% of our performance. So just adding a lot of cores, well, you will get some extra performance, but you're not getting what you might think you're getting. So you pay a lot for adding the last few cores. This is probably why a lot of systems like games, they don't take advantage of a lot of cores. So a way to get somewhat around this is to use more virtual machines, which brings us back to our virtual machines here. So we have these 4 servers here, and I have gone back and configured all of them to have 4 cores. We're kind of dividing the 16 physical cores out into 4 different virtual machines. So I want to show you what that does. So we will take our manager here. So right now I have been testing 4 frames, naturally, on all of them to make it the same thing. So when we have 4 machines, we want to do the same. We want to give all 4 machines 4 frames. So we need to alter this number, and it starts at frame number 1. So including number 0 and all the way to 15, that's 16 frames. And we go up and we will add that to network rendering, and we will call that, reach number 16 actually, that's a coincidence. And we will connect, see our 4 servers here, and I'll just select all servers 1, 2, 3, 4 and submit that job. And yes, override that, and they will be making my 16 frames. We can kind of go see that here. This is number 1. That will start up in just a minute. So we see that it has 4 CPUs working. So it gets 4 little squares, and I'm sure my server will be ramping up out there, because now it's suddenly using all of its cores. Well, I have been testing for quite a bit, so it's might be getting used to this. And the bloody server needs updates. Go away. Go away. We're filming here. And the next change is not that big. The way this works, we could go and see that. I've shown this in multiple old videos, but if we look at this, we have the 4 network rendering servers down here, and they are being given one frame at a time. So we have job number 16, and we can kind of see them working on that. Out here we can see what server has been giving a specific task. They should be pretty much alike, those servers there. Oh, actually, when we watch the frame here, we can see that the propeller is starting to stir up the water. So probably the frames are going to be taking longer. It looks like the first 4 frames was given to each server. Then the next frames becomes more and more difficult because there are foam in the water. So it's I didn't think about that. Server number 1 was the last one to complete. There. So we did our 16 frames, and I will have to calculate how long that took. It took from 12:55:40 to 12:59:01. Okay, I calculated that took 201 seconds. So now I will go in and I'll just give server number 1 all of those 16 cores. That server should have the maximum amount of speed available. So I'm gonna start up that server and start the test, and we can see how it does. Okay, the server is back up, and it's gonna be starting rendering with 16 cores. This should be the maximum amount of speed that one server, even if I go and install Windows directly on the server out there, it's very compatible to that. A funny thing in the new 3D Studio Max here, if you see at the very end of the render of the frames, these are called buckets, those squares, they become smaller at the end. Like when it's almost done with a frame, it reduces the size of each bucket. This was a problem back in the day when you could wait quite a bit for the last bucket to be done. So they have kind of gotten around that by reducing the size of the bucket at the very end of the render. So we are at frame number 6 of 16. So it's going to be very interesting to see how long this takes compared. It looks very impressive when it has all the cores working. Now look, there's one bucket that is missing there, so that took extra time. So the number of frames, effect frames in our short film here with the submarine is about 3,000 frames. So it's not that. This is low resolution, so it could be a bigger problem. Let's say that we render it out in 4K. Well, then this would probably take 4 times as long. And this is why we are setting up a couple of servers to do this. These render servers, they're really easy to just copy to the next server and the next server and the next server. And of course, they need some physical cores to work on. So right now we are just testing on this one physical server, but we will be copying them over to another host, and that way getting all power to if the software knew which bucket was the hardest last time and just started there, the time used would go down. There we are again, one bucket missing. Last frame. Hope everybody can see that it's the end of a submarine. So here was the result of number 16. the test number 16, the one we did before. We can see some of the frames, they take over a minute, each of them. And then there is a few here in the middle that are like 44 seconds is the lowest. And then it goes up over a minute at last one. If we take the test we just did, you can see the first frame, it starts the program and everything, so that is still about a minute. It's faster, it's a faster minute than over here, a minute and 25 seconds. Here is only a minute and 2 seconds, and then it's just 12 seconds, 13 seconds, and it becomes easier for it. Each frame is 20 seconds and so on. But if we do the timeout here, okay, I messed up a little bit. I have been looking at these numbers, and this is when the first frame is being assigned, and this is when the last frame is being assigned. It doesn't really show how long. Well, it should add this time to when this was assigned, and it does that over here, where it shows me when was the job submitted, when was it started, and when was it ended. So it's really these two times that it got the job here, it ended the job here, and I've calculated those, and that means I also calculated wrong in all of these tests. So I have fixed that. That took a while. Here we have the charge, but it just makes this even stronger. Just one core and doing 4 frames. That now took 459 seconds, which is 100%. With 2 cores, the same job took 338 seconds. 3 cores, 233 seconds. And 4 cores, 188 seconds. And all the way up. And that makes so that the losses for adding extra cores becomes way bigger. You can see already adding the second core, we lose about 37% of what we could have expected. It does not go down with half the time. We lose some of that. We had one server with 16 cores doing 16 frames. That ended up taking 326 seconds. Same job with 4 servers with each 4 cores took 271 seconds. That means that we saved 55 seconds by making more servers doing the same job, even though they are running on the same machine, physical host out there. So this very clearly shows that adding more machines, handling the cores, is often a good idea, and you can save a lot of time testing this. This does not only apply to like rendering stuff, it could also apply to database servers or mail servers or anything else like that. I can't say when it will apply, but also if you just do this test and do a benchmark of your CPUs, you will see similar results. Losing performance when you add a lot of cores. You're not getting 100% when you're doubling the amount of cores you have. Big surprise. And it becomes it still goes down, like 16 cores are still the best down here. That now takes 102 seconds, and then it goes up a few seconds when we add hyperthreading. So it also needs, we don't get any benefit out of the hyperthreading here. Actually the other way around, it becomes bad. The best you can do if you want maximum performance is actually to make 16 servers with 1 core each, but then it becomes difficult to manage all of this. So I usually have 4 core machines to do this rendering job, just so that I don't have to manage a ton of machines. Well, so that's me playing around with 3D Studio Max, doing render tests, see if I can maximize the performance of my server to get this to render the fastest as possible. Which is, you have to see the good things and the bad things, and creating 16 servers on one physical host, you might move the bottleneck somewhere else, like now you have 16 servers that have to get new jobs. So the hard drives might be the slow part, or the RAM, and the workload. Just how many servers do you have to deploy to actually do this? Your mileage might vary. You might be okay with building 2 core servers and having 8 servers on there. Might be fine. It's cool. You can save some seconds there. So thank you very much for watching my videos. Do subscribe to my channel so that you can see me again, and have a really nice day. Bye bye.